Okay, we're in section 68 now. Contents for you to look at, read, try to understand, examples for you to look at, try to understand, and then you're going to get busy doing the exercises. This is a tough section, though. There's no doubt about it. It's tricky and tough. All right, my name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. The PDF document at this point in time is only being made available to the participants in the Prison Mathematics Project. I do understand that many students and teachers may want access to the document. It's not published yet, but it will be published. All right, if you need to reach out to me for whatever reason, including you're interested about getting a copy of it, please email me. My email address is b as in boy, the @ symbol, nnon.us. All right, so what are you doing over here? You're going to read through the section over here. It's simultaneous quadratic equations with more than one unknown. And this can get tough. There's no doubt about it. It's also going to be tricky. I do want to point out the point of this is, not to be able to solve every single problem you get, but to realize that problems can be struggles. All right? So far, we're looking at this over here. I notice the first equation. That's quadratic. I got a bunch of squares in it. But the last two equations are, they're linear. All right? This is a three-dimensional system, by the way. So one thing I would do is I would just play around with it, but I would concentrate on these two first. And what I notice first, if I just add those two equations together, let me put that down for you. If I just add those two equations together, what would you get? Let's write that down. You would get 3x minus y. The z's would disappear. I got to make sure I'm doing this right. 2x and x is 3x. Minus 3y plus 2y is minus 1y. The z's disappear. And 11 minus 6 is going to be, let's see, what's going to be 5, right? All right. So I'm going to say, I could solve for y now. What's y? Y would equal 3x minus 5. All right. I think I did okay with that. Now, I had y in terms of x, and that may be useful, but I still have problems. I still have that z to deal with. So what I'm going to do is I'm going to take this equation now, and I want to see if I can get z in terms of x. I don't know if I can do that. So let's write this down. X plus twice the y. Well, what's the y? 3x minus 5 minus z equals minus 6. And what do you get there? Let's write this down. X plus 6x minus 10 minus z equals minus 6. Let's see, what do you get? You get 7x. Let's see, I'm going to add 6 to both sides, so minus 4. And add z to both sides to get this. Now, this looks like it might help me. So I got this, and I have this. Now, if I didn't do any outrageous errors, I'm going to take this and plug it into the top equation now. And what do you get? You're going to get an equation in x. I'm hoping it's going to be really simple. All right, so you get x squared plus y squared. Well, this is y. I'll just write down that squared. 3x minus 5 squared plus z squared. Well, I believe this is z, and that's 7x minus 4 squared equals 14, right? Now you get x squared. This will be 9x squared minus 30x plus 25 plus, let's square the next guy. That's going to be 7 times 7 is 49x squared. Let's see, minus 28 minus 56x plus, that's x, plus 16 equals 14. And I'm going to do my x squareds now. 59x squared. That doesn't look good. Let's do our x's. Minus 30, minus 50, minus 86 x's, I believe, right? Let's see. That's a 14 over here. I'm sorry about that. It doesn't look like a 14. So if I 25, 16, take away 14, I get 27. All right, so the next thing I want to do is see if I can solve that equation for x. And there will be two x values for that. It's quadratic. All right, now I realize a lot of times when you're working problems, you're wondering if you're going in the right direction. Now, I'm not saying I'm going in the right direction, but I am in a direction where at least I could probably figure out what the x is. All right? Now, I know it looks tough, but before I go forward, I want to make sure that you realize we do provide support in the place of an answer key. So let me just show you what I mean by that. I'm going to look for, I'll tell you what I'm looking for. I'm going to look for this, and I see that right here. I'm going to look for this. I see that right here. And I'm going to look for this, right? So I want to see if I'm going the right direction, and I'm seeing that right here, right? So I hope you see that. 59x squared minus 86 plus 27. So at least I'm going in the same direction. But I got to be perfectly honest with you. I realize a lot of students struggle with this factoring business, and I do too. Right? I'll be honest with you, I do too. But I'm kind of looking at it, and what I want to do is just, look at these numbers over here, and it's not easy. I mean, you could do the AC rule, but I want to be honest with you. 59 times 27, and that's going to be, I need to find two numbers that give me that product, and I got to find two numbers that when added together would give me minus 86. Well, I'm going to say they're both negative numbers for certainly, all right? So this comes my problem is figuring this thing out. And, the 59, I'm going to try, you know what, 59 and 27, I'll write that down for you. 59 and 27, like if you add that together, what do you get? You get 1686. Wow, that's a miracle. Let's write that down. So I'm going to say minus 59, minus 27. And minus 59, minus 27 does work. Let me write that down for you. Get my little eraser out. And I'm going to put this down for you. So you can get, 59x squared minus 59x minus 27x plus 27 equals 0. We're not home yet. Factor out 59 from the first two terms, and you would get x squared. I'm using the AC rule, by the way. I'm sorry, I made a mistake already. I got to erase this. It's 59x. Sorry about that. You would get x minus 1. Factor out minus 27 from the next two terms. So I'm factoring by grouping. That would give me x minus 1 equals 0. This factors to x minus 1 times 59x minus 27. All right? I'm going to go back over here. I'm going to point out that that's written over here as well. All right? Now, what do I have to do now? I think I know the x. All right? So I think the x is going to be 1. I'll write this down for you. Or the other answer, it could be, this is going to be tough. So it's going to be 27 over 59. Okay? Now what I want to work backwards, and I'm going to put down now y. I'm getting that here. And what would you get? You would get 3 minus 5, which is minus 2. And I want to write that in a z. I'm going to use this to get the z. So what'd you get? 7 times x. Well, 7 times 1 is 7. 7 minus 4 is 3. So I got one solution. I'm going to point out where this is. This is right here. The other one, again, I'm not saying they're right answers yet. The other one is going to be, let's see, x equals, this is more difficult to do. Well, 3 times 27, right, I'm doing this over here, is 81 over 59 minus, well, I got to do 5 times 59 now, right? I'm just going to do 5 times 60, which is 300, minus 5, which is 295. Again, we have an answer key to look at. It's more work. That's why I say it for a second. It's 59. And let's see, 81, 295, that's going to be 214. Let me make sure that's right. 214, 80. Yeah, that's good. All right, so I got the x. Now let's do the z. And what's the z going to be? I'm looking at it over here. It's going to be 7 times 27. I'll write this over here for you. This is my chicken scratch. That's 49. And then, 7 times 7 is 49. And then 7 times the 2 is 140. So 189. Whoops. Over, what was I saying before? Forgot, I lost track here. 59, sorry about that. And then minus 4 times 59. Well, 4 times 59, it's not bad. I would do, 4 times 50, which is 200, minus 4, 196. And what would you get for Z? Well, let's see again. I'm sorry, this is 59. What do you get there? Let's see, 189 minus 196, definitely a negative number. And you get 7. I must have made a mistake somewhere because I'm not getting the same answer. So someone says, if you make a mistake, what do you do? Well, I guess I have to do something. All right, I'm going to erase. I'll rethink. And this isn't going to happen to you, all right? Hopefully mistakes happen towards the end, not in the beginning. Let me erase this work over here, and I'll go at it again. All right, so what do you get? Z. You know what I read? I noticed another mistake over here. This is Y. I'm glad I'm paying attention. And what's Z? Let's write down again. It's 7 times 27. Let's see if I did that right. 7 times 7 is 49. 7 times 2, 140. So that's 189. I'll write this over here. Over 59. Minus. And now I got a 4. And I have to do 4 times what? 4 times 59, right? So it's, that's where my mistake came. So it's 236. Sorry about that. Over 59. So what do you get there? Let's take a look. Z equals 59. These are nasty looking numbers. I know that. 59, and then, 189 minus 236, definitely a negative number. That's 36 and 11, 37, 47. All right? Do I see those answers? Let me point out I do. I see this. I see this. Whoops, made another mistake. That's minus. I see this. Whoops, sorry about that. Really screwing up here, aren't I? I see this. And I correct my errors. It was nice to have an answer key. I'm building up my strength here. So when I get the exercises, maybe I'll be a little bit better. Look, I did good. Now, someone just say, could you visualize this? These solutions can be visualized in software, but it's three-dimensional. Right? It's three-dimensional. All right, why is three-dimensional? You get X, Y, and Z. I would say that the graphics for a three-dimensional picture, at least with my skill set, is probably not going to look too good in the notes. That's why I don't do it. All right? But I would recommend something. I would recommend this. And someone says, I don't want to do it. And you know what? I really don't want to do it either. But at a minimum, I would say checking is not a bad idea. Right, let me go through the check for you. Now, the check is going to be in the original system. And I think, 1, 2, 3 is easy to do. So let's write this down. I'm just going to do the X first. The X is 1. So it's going to be 1, 2, 1. Now, the Y is minus 2. So that's going to be plus 4. Plus 6, and then you're going to get minus 4. I'm just checking one number at a time. Now, the Z is 3. That's plus 9. And the Z is 3, so plus 3. And then minus 3. Let's do the addition, see if we're getting what we expect to get. 1 plus 4 is 5, 14. Yep, got it. 2 plus 6 is 8, 8 plus 3 is 11. Yep, got it. What I'm getting these things over here. Let's see, 1 minus 4 is minus 3, minus 3 minus 3 is minus 6. I'm getting that too. Now, I would also say you probably should check this one over here. What's difficult about that? Well, you know what? Computationally, it's more challenging for students, and myself too, right? You may want to use a calculator to check those out, and there's nothing wrong with doing that. All right, now the next one, again, I'm looking at these things, and I got to be honest with you, I find them very difficult to deal with, all right? But, I kind of see something about it. I'm not saying it's going to work out for me, but I really don't want to, try to substitute, well, maybe try something. Let me try this. I'm going to try to multiply everything together. This may not work, by the way. Boy, it's getting really bad looking, isn't it? let's take a look at that. Well, you know what? I'm starting to see something over here now, and I'm seeing this. I'm going to make it shorter. I didn't see that before. I'm seeing 2 factors of y minus b. I'm seeing 2 factors of x minus c. And I'm seeing 2 factors of x minus a. And that equals a squared, b squared, c squared. Now, granted, these parameters make it much more difficult to deal with, but right now I'm not too worried about that. And I'm going to write this down. I'm going to use the square root rule. And what do you get? And again, it may go nowhere. And that would be plus or minus a, b, c. Does that help? I think it does. I'll tell you why. If you look at the first equation, I could take this and divide it into this. And let me tell you what you'd get if you did that. The y minus b would cancel, the x minus c would cancel, and you'd be left off with x minus a. And then, let's just be real careful about this. The plus or minus abc is going to be divided by a squared. What's that going to be? Plus or minus bc over a. I know what x is now. So what's x going to be equal to? X will equal, I'm going to do a plus or minus b squared over c, whoops, over a, sorry about that. X equals, and we'll check the key later. This would be a squared plus or minus bc over a. All right? So, let's check. Well, that's a miracle. We got it right here. Okay? Let's do the other one. And I'm looking at the second equation. I'm going to do the same thing. All right, what are we going to do? Well, I'm going to divide this by this. Well, the x minus c would disappear, x minus a would disappear, and you're left off with y minus b now. And again, the plus or minus abc is divided by b squared, so I get plus or minus ac over a b. What's y equal to? B plus or minus ac over b, or y would equal b squared plus or minus ac over b. Let's see if we got that. We got it. All right, success, success, success. Let's do the last one. And again, I'm going to divide this by this now. And what do you get? Well, the x minus a disappears, the y minus b disappears, and you get z minus a. And then you get the plus or minus abc divided by c squared, so you get ab over c. And so what's the z going to be equal to? I'll write this down for you. It would be c plus or minus ab over c, or c squared plus or minus ab over c. And again, we're just doing a chicken scratch, see how we're doing over here. And did I get that? C squared plus ab? Yep, over c. Bingo, got it. All right, let's keep going. Then again, I'm telling you, these things can be incredibly difficult to deal with. All right, incredibly difficult to deal with. What I want to do now is I want to just say, you know, I'm going to say that you can't have to observe what people are doing in the problem sets and follow what they're doing. And I'm going to do that now. I'm going to look at this. And I got to be honest with you, there's many things you could do. And I'm not going to tell you that they're going to be a good things to do, but there's many things you could do. And I'm going to point out what they say to do to start off with this. And it can't hurt to listen to advice over here. Wells is really good at giving advice about what to do. The problem with giving advice, by the way, it may not be followed. And I'll be honest with you, the more advanced you become, the less likely you're going to take someone's advice. But I'm not saying this is the only way to do it. But if you added those three equations together, I'll write this down for you. If you were to add these three together, let me write this down for you. Now, what I've noticed a lot of times, and I've been teaching a long time, you give students advice about a problem, and they fail to heed the advice. A lot of times the reason they fail to heed the advice, they don't understand the advice. But I got to write this down, and I got to understand what they're telling me to do. They're telling me to add all this together. And what would you get over there? A squared plus B squared plus C squared. Well, immediately what I notice it's factorable. So I notice that x plus y plus z factors out, and we left off with x plus y plus z equals a squared plus b squared plus c squared. And what do you get over there? X plus y plus z squared is equal to a squared plus b squared plus c squared. Let me point out, that's what they give me right over here. When I followed the rest, I got that. The next piece of advice they give me, they say use the square root rule. Well, let's take that and see what you come up with. What do you get? Let's write this down. You would get x plus y plus z equals plus or minus the square root of a squared plus b squared plus c squared. Let me tell you where this is, right over here. The next thing they tell you to do is to divide each of the three equations by this thing. Let's do that one at a time, all right? So let's do the first equation. And again, this is the first equation. If you divide by this on both sides, what do you get? Let's write this down. You would get x equals a squared over plus or minus the square root of a squared plus b squared plus c squared. Now, granted, they simplify it. That's right over there. Let's do the next one. What's y going to equal to? Well, you're going to get b squared. Again, there's a cancellation over there. Plus or minus a squared plus b squared plus c squared. I'm seeing that there. Again, it can't hurt to have advice given to you. What's the last one going to be? Well, let's take a look. Well, you'd get, let's see, z, and then you get c squared over plus or minus a squared plus b squared plus c squared. And I'm seeing that. All right, not bad. All right, let's take exercises finally. All right, so I struggled with this too. I'll be honest with you, that this was a tough section for me. All right, so what do you mean by tough section? I had to look at these problems over here. No answer key, no advice, yada, yada, yada. I had to look at this, rely upon what I saw in the past, which are those examples we just went through, and work on it. Now, certainly, my advice to you is to work on it. I mean, work on it. I mean, there's many things you could be doing over here, many things, but work on it. Don't give up. The other thing is, don't look at the answer key until you spent a considerable amount of time trying to figure it out. Does it take time and effort? Of course it does. Like any game you're going to play, it takes time to hone your skills, all right? What's that? What are you doing? You're basically exercising. You're preparing for seeing patterns and problems. But what did I do over there? I kind of outlined the procedures I did. Now, you might look at that and say, well, I'm trying something different. Maybe you did. I'm just claiming these are the answers, all right? Next one. My advice to you is this. Please try to do it on your own. Don't look at the answers. Try to do this on your own. Try. Might take a half hour. It might take 2 days. It might take the rest of your life. Bottom line is, everyone gives up at some point in time. You may have to look at the key. This one, same story. Please try before looking at the key. Please try before looking at the key. Please try before you look at the key. Please try before you look at the key. By the way, even after you look at the key, you still may be confused. You may say, I don't like what you're doing. You want to try something different, right? Were these questions difficult for me? Of course they were. It's not like I look at them and say, oh, gee, this is easy peasy lemon squeezy. It's never easy peasy lemon squeezy when the problems are written like this. These are tough problems, all right? But there's a lot of them. We recommend you work with them. You notice when they get higher in the number, they get more difficult to do, by the way. We're at 10, 11. And yes, I worked on every one. Yes, I think my answers are good. Yes, I spend time and effort on doing those things. What number is that? 12? Not look like I give you 12 questions. All right? Sage. What's nice about Sage? It's a computer algebra system. That's what's nice about it. And that's, people that know algebra really well were able to code algebra into a machine so the machine could do it. And machines are really good at doing stuff that we're doing. They're much faster at it, though. So I would say download the application if you got a computer that can handle it, or otherwise just use the interactive web-based application. And you know what? I just want to just briefly go through this over here. What's this over here? I'm defining 3 separate variables. I'm writing down 3 separate equations, and then I'm asking Sage to solve the system. And Sage remarkably solves a system that, whereas it would take me a lot more time to do it, you'd be shocked how fast Sage is doing this stuff over here. So I know the argument from a lot of students saying, well, if Sage can do it, why would I need to learn to do it? What you're learning is pattern recognition. That's what you're learning. You're learning how to recognize patterns in problems. And that's really the most important skill you're ever going to acquire, to be able to see patterns in problems, all right? So I'm going to say some problems are, kind of trivial, but other ones are more advanced, all right? Patterns are really important to recognize. Now, if you believe you're witnessing my work, and you spent a lot of time doing it, and you believe there's errors, please reach out to me. Again, my email address is B as in boy, the @ symbol, NNON.US. If you report an error to me, I'll check it out. If it's an error, I'll correct it. It'll be updated, and I'll give you credit for it. I really do appreciate you paying attention. Thank you.